Okay, here we go. Bandit level 12 to level 13. So the level goal. The password for the next level is stored in the file data.txt, which is a hex dump of a file that has been repeatedly compressed. For this level, it may be useful to create a directory under /tmp in which you can work using mkdir. For example, I'm just going to call that make directory. Make directory /temp/myname123. Then copy the data file using cp and rename it using mv. Read the man pages. So commands you may need to solve this level. It's added a few on the end here. And helpful reading material, hex dump on Wikipedia. So as usual, I would suggest looking at that first, and of course giving the exercise a go if you want to. But let's talk about this a bit. So there's quite a few new things going on here, and there's some. It looks like we're going to use quite a few commands here. So let's have a little look. We've got our data.txt. As usual, I'm just going to cat to see what it looks like. Okay, so this is our hex dump. Now, I guess briefly I will just mention what a hex dump is, or at least sort of try and explain it to you a bit. Now, a hex dump is just representing the binary data of a file in hexadecimal. Hexadecimal being a numerical number system of base 16, which just means that each digit is going to have a potential value from 0 all the way through to 9, but then also A, B, C, D, E, and F. If you don't know about base 16 number systems, then really I'm not going to try and explain them here, because it will take me a little while to go through it. But basically, by doing so, by writing things in base 16, it makes things a lot smaller and easier to manage. Basically, 1 byte of data becomes 2 hexadecimal digits, because one of them can represent any 16 values, which is the same you get from 4 bits if you're in binary. But okay, so if you don't know about hexadecimal, I would definitely suggest going and reading a little bit about hexadecimal numbers. And so yeah, this hex dump is just the hexadecimal representation of the data. This left-hand column here is like the sort of like address space, or it's like the offset. It starts at 0000. Here we're in it at 10 in hexadecimal, so that's actually byte 16. So this is byte 16, because these are 2 bytes a piece. So you've got 2, 4, 6, 8, 12, 10, 12, 14, 16. So 16 bytes here. So this starts at the 16th byte. And this right hand side is the ASCII representation of that data. So sometimes it's going to be represented by an unprintable character, and that's going to be where these full stops are. They're going to specify it's unprintable, but sometimes you're going to get some ASCII text that you recognize in there. But here we go. So that's a very brief overview of hex dumps. We've got this hex dump here, and what have we been told? Sorry. It's a hex dump of a file that's been repeatedly compressed. So we're going to have to revert the hex dump, and then we're going to have to decompress it. So because decompressing and writing, reverting a hex dump is going to write to the directory, it's suggesting us to work in a folder or a directory under the /tmp directory. That's because the tmp directory is a temporary, that's what it stands for, and then they get flushed, they erase when the system reboots. So this is often where programs put temporary files and such that it won't need after a system reboot and such. This folder is normally writable for any user, so what we want to do is use cd to change directory and go into the temp. Now the mkdir command is the first new command we're going to use in this exercise. That just means make a directory. So we can make a directory using that command, and I'm going to just call it D. Why not, hey? So now, although we can't ls, because we've not got read permissions on the temp file folder, we can still move it into our new directory, right? Which we should be able to read. So we can, if there was anything in here, we'd be able to ls and read that. So what we need now that we've got this new directory, I'm going to cd. If you this is going to be one that's full of new information. This video. If you do cd and just with nothing else, it's a shortcut to change directory back to your home directory. So I'm just going to cd back ls. So we want a copy of this data.txt file in our new temporary directory, so that we can sort of work on it and write and do all this stuff without being restricted by our permissions. So we need to make a copy. So here's your next new command, cp command. Cp is copy, and the syntax is just the file that you want to copy and where you want to copy it to. So we want to copy it to temp D and hit enter. So now we should have a copy of this file in our temporary folder. So I'm going to cd back to it and ls. Yep, and it's there. Okay, so we have a hex dump, right? We need to somehow go back from that hex dump back to the original binary data, which should be compressed data from this hex dump of a file that's being repeatedly compressed. So we need to revert from the hex dump and then decompress. So how do we revert? Now I'm going to just control an L. Well, that's going to be with this command here, xxd. So if we go to the man page of xxd, that allows us to make a hex dump or do the reverse. Doing the reverse being the important bit here, right? Now in the synopsis it even gives us the command we need. xxd with the flag r is revert, and then the in file and the out file if you want to specify where it goes. But just to show, the flag revert. So reverse operation, convert the hex dump into binary. So that is what we want. So that's brilliant, okay? So let's look. We've got our data.txt. We're going to do the xxd command on it. Revert data.txt. So that's something I didn't read, right? What has happened is it's taken that and it's taken the result of this and it's pushed it to standard output. So it's come onto the screen. It's not automatically made a file or something like that, which I assumed it would. So that was a mistake. So what we need to do is specify the file where it's going to go, data2.txt. The reason I knew I could do that was just the man page. It said next to the in file, it said out file, so I knew that by putting another parameter it would write the changes to that and write the result to that specified file. So now we've got this data2.txt in our... I'm going to make this a little bit bigger. Okay, so now we've been told that this data2.txt is compressed data. Now if we want to decompress it, we need to know by what standard it's been compressed. I'm sure everyone's familiar with the idea of compression. It's just taking a file and essentially using smart mathematical algorithms to make it smaller in size, which obviously has lots of benefits. And so we need to know by what algorithm that's been compressed so that we can use the correct decompression algorithm, right? So we're going to use our trusty file command. File command on our data2.txt. Great. It tells us it's gzip compressed data. The name, it even tells us the name that the file used to be before it was compressed. So, okay, brilliant. So now what I'm going to do then is show you how to decompress gzip compressed data. Now, you can see here we've got gzip and we've also got bzip2. So these are two compression programs that we use in Linux. They're used a lot, and each of them has its own decompression command. There's a couple of ways you can do this, but the way I normally use is you can use gzip to compress the data, or bzip2 to compress the data, and you can usegunzip to unzip gzipped data, and bunzip2 to unzip bzip2 compressed data. Now, one small sort of foible or finicky little detail is that these programs want to see that the file you're decompressing has the correct file extension. So it's going to look to see if it's a gzip file by looking at the extension of the file. So, like for instance, we've got .txt here to sort of imply that it's a text file, and we've got data2.bin here to imply that it's a binary file. We need to have .gz if it's a gzipped file, and .bz2 if it's a bzip2 file. So what that requires us to do is use another command. I realise that there's going to be many commands in this. You can see things are starting to get a little bit more complicated. So we need to rename our file. We need to rename it with gz at the end. I'm also going to rename it to data2.bin as well, because that was the original file, so why not? So the way we do that is with the move command. Now, move is just mv, and you can use move to move things from one directory to another by specifying the file and then the destination. Or if you give a file and then a destination in the same place, it's the same as renaming it, right? So for instance, I'm going to move data2.txt and I'm going to move it to data2.bin, but it's gzipped data. So I'm going to give it an extension of .gz as well. Hit enter. And now if we ls, you can see we've got this data2.bin.gz. And it's gone red because it's recognized that this is compressed data, and it's given it a nice color to sort of make it stand out. Okay, now I've done all that rambling, we can go through the process of unzipping it. So all we do is gunzip, and if I hit tab autocomplete, it looks for the file that has .gz at the end, and hit enter. So that's done that. ls, and you see how it's removed the gz. That's what it does basically after it finishes decompressing it. So let's have a look and see what our bin file is. Okay, it's bzip2 compressed data. So now we need to decompress it as bzip2. So we need to make it the correct file extension again. So we're going to data2.bin and move it to data2.bin.bz2. So now we've got this, and we're going to unzip it with b unzip 2. Oh, didn't put my... Hit tab and enter. I'll have a look. And we're back to here again. So we're going to look to see what it is now. Okay, so data2.bin gzip compressed data was data4.bin. Okay, so we've now got gzip compressed data, so we need to correctly make the file extension again. So we're going to do data2.bin, and this time we're going to change it to data4.bin.gz. We're going to look. Okay, g unzip and ls, and we've got data4.bin. And so I'm just going to keep doing this, and just I hope you can follow this. Okay, so now we've got a tar archive. So another way of sort of another this isn't compression. Well, not that I'm aware of anyway. I don't think so. No, it's not compression. A tar archive is like a way to group a load of files into another file. An archive. It's used a lot. It's used a lot in conjunction with gzip as well. You get these things called tarbles, which are like compressed tar archives. So let's just have a look at the man pages for tar, because tar is the command that we use for tar archives. So tar, an archiving utility. So we need to extract our tar archive. So we're going to just go through, and we're looking for extract, and here it is. Okay. But one thing we need to be aware of when we use this extract, I don't know if you see it up here, is tar with the X flag requires the F flag with the archive name. So that's one thing we need to be aware of sometimes. Make sure to look at the synopsis of the file, of the command, right, in the man page. So okay, so we can now tar X, and now we could do this, but I'm going to just do it like this with data4. Oh, okay, almost made a mistake there. So similarly, as we did before, tar archives end with the extension .tar. So we're going to want to change data4.bin, and you know what? I'm going to call it data5.bin. Oh, .tar, just for the. So now it knows it's a tar file, a tar archive. Sorry. So now we're going to use tar data5.bin.tar. Okay, and so now you see how with this, with the tar archive, it's left the archived file, and it's taken the contents and put them separately. Now there may have been a way to alter that so that it overwrites or something, but that's the sort of default behavior. So it's now data5 that we're looking at. It's another tar archive. So we're gonna, wow, this one's gonna be long, this exercise. So we correctly put the extension on there. I didn't do data 6 that time, maybe I should have put it as data 6, but then we're going to do, yep. And in there was data6.bin. Okay, so data6 bzip to compressed data. Okay, so we need to put the correct. I'm going to call this data7.bz2, because just why not? .bin.bz2, I guess. Okay, and then we're going to unzip 2 and hit tab. Data7. See what data7 is. Oh my goodness, this is another tab. Okay, move data7.bin to data8.bin.tar ls. So this is just the way you've got to do this one, unfortunately. So data8.bin.tar. So we've got data8 now. So data8.bin. gzip compressed data. What's data9.bin? Okay. So we're moving it to data. We're calling it data9.bin.gz. I hope you're able to follow this, and I'm not just. Okay, so now we've got this data9.bin.gz. So we're going to unzip data9.bin.gz. Yeah. So now we've got data9.bin. So let's have a look. Oh, yes, wonderful. Okay, ASCII text. That is perfect. That is what we want to see. That is really long. There was a lot of stuff going there, but it was just the same process, right? Just constantly renaming to get the right file extension, and then decompressing, rinse and repeat, essentially, right? Okay, let's just make sure that this is. Yeah, wonderful. Great. So I don't know why it was called bin, really. I guess that's fine, but you'd think it would be text, right? But yeah, okay, the password is here. So yeah, I hope that made some sense. We'll probably talk more about file extensions and things like this. The actual file command, I think, uses like the first 8 bytes of each file to tell what the actual real file is, if you know what I mean, what the type of the file is. Anyway, I'm not going to go into that. This has got way too long, and there's been lots of different commands being used here. But I hope that makes sense, and we've got there in the end. And I'll see you in Bandit 13 to 14.